Hello everyone. In this video, we are going to present the basic process termination in Windows and Linux. Here are myself Manasa. Here are my team members Divyashri, Sinchana, Bhavana, Bindu. Uh, I'm going to explain about the key concepts of Windows. This provided code demonstrates the creation of child processes in a Windows environment using the create process function, which is a core function in the Windows API for process management. Here are the key concepts. First one, infinite loop. The program continuously spawns a child process until manually terminated. This often used in server-side applications or background tasks that need to constantly spawn new workers. Second, create process function. This is used to create a new process in Windows. It requires various parameters like the executable name, process security attributes, environment settings, and more. On failure, get last error retrieves the error details. Process information stores information about the created process such as its process ID and handle to the main thread. Next, handle management. Close handle is used to close the process and thread handles to freeze resources. Next, real world scenarios will be explained by Bhavana.
The real world scenario, first one, several application. In a several context, this could be used to snap new workers process for handling multiple requests concurrently. And for example, web service might launch new process for each request. Second one, branch process. A program is continuously create a process to handle a large sets of the data and tasks, such as a data processing application that snaps new process for the each data. Third one is resource management. All through this code demonstrate infinitely snapping of process in a real world scenarios. You want to limit the number of process created to avoid overloading the system. Fourth one, it is automation. It means testing. This is approach could be used in automation tools that continue launch process to the load, or automatic testing where multiple instances of a program are needed to test behavior. Next, we'll continue Divya.
So here we have the code of the Windows, that is the Windows in a Windows environment. First line, which is hash include ratio.h, which is used for the creation of the input and output operations, that is Windows operation, creating a process. The second line, here comes the standard libraries, that is in handling of the input and output operations. Third line, we are going to explain about the main function, and for in the fourth line, we are going to explain about the while loop, infinite while loop. The startup info, which is used for the creation of the child processes. The process information, which is used to create the process and store the memory. The seventh line, we are going to indicate the size of the memory, that is SI. And in the eighth line, we are going to explain about the startup information, that is a creating of a structure. And in the ninth line, we are going to explain about the memory, that is the size of the PI. And here comes the if loop, which is used for the creating of the process, which is null with the null program, with a null pointer, and printf, which is prints as a message, that is creating a process is failed, and returns the error message return 1. Here the printf process, that is created a child process with a PID, and here the process closes with a PI, and also it closes the handling of the thread, and it also returns the error with the message return 0. Now I'm going to compile the code. So here are the errors with the 0 errors. So it is the output that we have got, that is a create process at the failed 2. It is the what we are going to get the code output for the Windows. The next further will be continued by Bindu.
Next, we move on to the Linux code. In Linux code, I am going to explain the key concept and real-time scenarios. In key concept, the fork. Create a new process by duplicating the calling process, the parent receiving the child PID while the child gets zeros. Child process. Second one is child process. A new process created by the fork which has its own memory space. Third one is parent process. The process called the fork. It continues executing while the child process running concurrently. Fourth one is get RPID returns the process ID of the calling process infinite loop while one. The, the parent continuously created new child process in an infinite loop. Exit status. The child process exit immediately after printing its PID while the parents continuously to the new forks. Next, we move on to the real-time scenarios. First one is process creation and management. Useful the scenarios where you need to spam multiple sub-process. Example, in web server handling the multiple requests concurrently. This model is fundamentals in scenarios where the tasks are executed concurrently, such as multiple user systems or task parallelisms. Third one is Zoe process. If the parent does not wait for the child process to terminate, it can lead to a Zoe process where the child has finished execution but still occupies an enter in the process table. Next, we'll continue by the Sinchana.
So here we have the Linux experiment where the first line includes the standard input-output library, which is required to use the functions like printf for output. Second line is include unist.h. This includes the header file, which provides access to various system calls like fork and get PID. Next, third line, we have include sys or types.h. This includes the header file which defines types used in system calls such as PID underscore P, the type of process IDs. So next one is the include stdlib.h. This includes the functions like exit for terminating a program. Int main, this is the main function. While one loop, here it indicates that it is an infinite loop. One always evaluates as true, so the loop will keep running indefinitely. And pi underscore tpid is equal to fork. This indicates the fork system call creates a new process and it returns. 0 is indicates as the child process. Last one we have the child process which will print and keeps creating a child process in the loop.
Thank you. This is a small assignment by our course coordinator Shivaranjani ma'am. So thank you for giving us this opportunity. Thank you one and all.